Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 9007000. Now, if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So we're timesing them, so 10 times 10t, 10 times 10 is 100, so it'd be 100t, 10 times 4 is 40. So our answer will be 100t plus 40. So when we say y is directly proportional to x, what we mean is whenever x doubles, y will double, whenever x halves, y will halve. Now we've got this proportionality sign here. And to make that an equals, all we need to do is introduce a k constant to the right hand side. So it's y equals something times x. Now to find out what that something is, to find out what that constant is, what we're going to do is feed in the value of y and the value of x that we have. So we're going to feed those in. So y is 55.3 and x is 7. So it would be 7k. And we're just going to put our lines in and solve this. So it's going to be divide by 7 both sides. And 55.3 divided by 7 is 7.9. And that's what k is. So we're going to rewrite this equation here, this formula here. Y equals 7.9x. And that is actually our answer. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other two in a right angled triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle. So it would be 49 squared plus b squared equals 68 squared. And 49 squared is 2,401. And 68 squared is 4,624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2,401 from both sides. So we've got b squared equals 2,223. Then we're going to square root both sides, and we've got b equal to 47.148, blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have a, we've got our b, and we're going to call x the c. So it'd be a squared plus b squared equals c squared, but this time a is 39. B we are given as 47.148, we've just worked that out, and we're looking for c. In fact, we can call it x now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3,744 equal to x squared, and we just get our lines in because we need to square root both sides, and we get 61.188 blah 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 is equal to x. It says it wants its two decimal places, so that will be 61.19. We've got to first of all work out how many parts there are altogether in our ratio. So we've got 51 saying yes, 7 saying no, and 13 undecided. So altogether, we've got 51 plus 7 plus 13, which is 71 parts. Now each part is equal. So to find out the value of one part, we're going to do how many students there are, which is 2,911, and divide it by the 71 to find out what one part is worth, how many students are in one part. One part's worth 41 students. So each one of those parts in the ratio is 41 students. Now yes, because it goes yes, no, undecided, yes will be the 51 there. So it's 51 lots of 41 students. 51 parts with each part representing 41 students. And when you multiply those together, you get 2,091. So our answer is that 2,091 students responded with yes. So the first thing we need to do is work out the mean for the data in the table. So to start off doing that, we're going to work out the midpoint of each group. So we've got 80 to 85, and to find the midpoint, you add the 80 and the 85 together, then you divide by 2. So this will be 82.5, then 87.5, then 92.5, then 97.5, and then finally 100 plus 105 divided by 2 is 102.5. Next we need to find the FT, which is just the frequency times the duration of calls. Now in this first group we're not timesing it by 80 to 85 or anything like that, we're timesing it by the midpoint, so our midpoint effectively becomes the T. So we're going to do 15 times that, which will be 1237.5, and we're just going to keep going and multiplying each of these together. And then finally 2050. Right, next we need to add up the frequencies and add up the FTs. So we're going to have the sum of the frequencies. So I'm just adding all this column up, and that will be 80. And we have sum of the FT. And so we're going to just add this column up here. And so that would be 7,450. So what this column represents is all the numbers added up together. This column represents how many numbers we have. So to find the mean, it's all of the numbers added together, which will be 7,450, over the amount of numbers we have, which is 80. So when you do that, we get 93.125. Now this question is about the improvement that we've made, or that the manager has made, the call centre's made. So we're looking at subtracting the 93.125 away from the last week, which was 105. So we're looking for improvement. And we're going to do 105, take away the 93.125. And that's going to be 11.875. Now it does ask for two decimal places, so that will be 11.88. So Factorise means to put it into a bracket, and it looks like it's a quadratic here. but it's actually just a linear factorising because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10, and that will leave 2 and 3. So that's the numbers done. Next, I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally, I'm going to look at the u, and there's just a u on both of them. I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now, always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. So let's look through this question to see what information we're given and what information we're looking for. So we're given the acceleration is 13 meters per second squared. We're also given the distance is 19, and we're also given the end velocity, which is v, is 34, and we're looking for the initial velocity. So which of these formulae include a, s, v and u? That's got a t in it, that's got a t in it, so it's going to be this one here. So let's write that out. V squared equals u squared plus 2as. So that would be 34 squared equals u squared, because that's what the one we're looking for, plus 2 times 13 times 19. Okay, so let's just work these parts out. And so we've got 2 times 13 times 19, which is what, 494. And it turns into a solving part, so we're just going to solve this. So the first thing I'm going to do is subtract 494 from both sides. And so we're left with 662 equals u squared. Then we're just going to square root both sides. And so square root of that is going to be 25.729 blah blah blah. And it says it wants it to 2 decimal places, so it's going to be 25.73. Whenever you have north lines, they will always be parallel. So what we have here is we have a straight line going through 2 parallel lines, which are our 2 north lines. And therefore this angle here is going to equal this angle here. And the reason for that is that the 2 angles are alternate, they're z angles. So we can say that that is 135, and I always like to try and show the examiner the reasons. So that's because it's alternate angles. And we know also that angles on a point add up to 360. So this red angle represents the bearing of A from B. And so to find this angle out, what we're going to do is just 360 take away 135. And the reason for that is angles on a point equal 360 degrees. And when we work that out, we get the answer of 225. So our bearing is 225 degrees. There's a lot going on with this question, so I'm going to start off just having a look at the total amount of money. So I'm going to do this in pence, so 2115 pence. And if each merit point is worth 3 pence, then we can work out the amount of merit points by doing 2,115 divided by 3. So that gives us 705. So there's 705 merit points. Next, have a look at the question here, this part here, where it says James has X merit points. Sarah has 4 times as many points as James, so she's going to have 4x. Robert has 69 fewer merit points than James, so he's going to have x minus 69. And we know that that equals 705 because we've just worked that out. And this feels like a solving coming on. So we've got x plus 4x plus x, which is 6x. Minus 69 equals 705. And we're going to add 69 to both sides. So we've got 6x equals 774. Then we're going to divide 6 both sides. And so we've got x equals 129. So x equals 129. That means James has 129. Sarah has 4 times more, so she will have 516. And Robert has 69 fewer, so we're going to take 69 away from that, and that will equal 60. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represents plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. The first thing we need to do is work out the area of the floor. And you'll notice that this is a trapezium. So with a trapezium, the formula is half a plus b times h. And A and B are the parallel sides, so these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula, so it'd be half A plus B h, so half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack, or 0.33 of a pack. So we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95, Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence, so I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. There's a very specific way to draw a perpendicular from a line. What you do is you get a pair of compasses and measure roughly 3/4 of the way between A and B, and draw an arc from point A, and we're going to draw an arc from point B. And you can see that the two arcs intersect here and here. So what we're going to do is just draw a straight line that join up where they intersect. Leave your workings out, your arcs, on the page when you do this to make sure you get full marks. With these questions, it's normally easier to view these as two separate triangles. So we've got a small triangle here with 19 and 47. And what I'm going to do is I'm just going to move this out. And we've got a bigger triangle here. And we've got, we've got a bit of, we don't really know what any of the sides are just yet, but we can work them out. Okay, now we know that both of these triangles are similar, and the reason is they share an angle and the lengths at the bottom are parallel, so they will be similar, which means one's an enlargement of the other. And we are given some information in the question that the ratio of BC to DE is 1 to 6. So BC is this length here, and DE is this length here. So we're actually given the scale factor because we know that 1 times 6 is 6. So we know the scale factor is 6, and it's asking us to find length AD. And so the corresponding length to AD, which is this one here. So all we need to do is get that 47, times it by the scale factor, so times it by 6 to get to our value. So it's 282. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4 w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4, w to the power 5. It's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4, w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4, w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. going to times the v to the power of 4s together. And remember, with indices, if you times two powers of the same base, and they're both v, then we just add the powers together. So that'd be 8. And we're going to add the w to the power of 5s together, so that makes 10. So it's 121 v to the power of 8, w to the power of 10. To find the perimeter of this sector, we've got to first of all find out the length of the arc, which will be this part here. And the formula for arc length is, first of all, we find out the fraction of the circle we have. So we put the angle over 360, and that will tell us the fraction of the circle that the sector is. And then all we do is we times that by the circumference, which is pi d. And so that's going to be 49 over 360 times pi times, and the diameter would be twice the radius. The radius is 7, so it would be times 14. When we do all of that, we get 5.986, blah, blah, blah. But that is not the perimeter yet. Perimeter needs to include, get the right ones, needs to include these parts here. So the perimeter will be the 5.986 plus a radius plus another radius. And when we do that, we get 19.986, blah, blah, blah. And we want to round it to 2 decimal places, so that would be 19.99 centimetres. You're expected to be able to draw a sine, cosine and tangent wave, and here we're asked to work out what y equals cos x looks like on a graph. Now cos x starts at 1, goes down to 0, then goes down to -1 at 180, then back up to 0 at 270, then back up to 1 at 360. But don't just join it up with straight lines. That will not get you any marks. You've got to make it look like a wave. And this is not the easiest thing to do, but they are very forgiving over how you do this. As long as it goes through the points, and as long as this bottom bit is a U shape and not a V shape, then normally you will get the mark. So although that doesn't look perfect, that will definitely get the marks. First thing we need to do is work out the volume of this prism, and it's a trapezium based prism. So the volume will be the area of the cross section, or area of the trapezium, times the length, how 3D the prism is. So trapezium is half a plus b h, and then times the length. Now A and B are the two parallel sides, which will be this one and this one. And then the H is the perpendicular line that hits both of them at 90 degrees, which is what perpendicular means, between the bases. So this will be the 25 meters here. So it's going to be half, and then we're going to add 1 and 5, times that by 25. The length is how 3D it is, so it would be that 10 there. So we're going to times that by 10. And that will give us 750. So it's 750 meters cubed. Now, there is a little formula we can make for the rate. So the rate of anything, for this, will be the volume gained over time. Now, with this question, though, we're interested in the time it will take. It says how long will it take. So we're actually looking at the time. So it will be time equals the volume, which is 750, over the rate, which is 15. So 750 divided by 15 is 50. So it will take 50, and let's have a look. It says per minute. So it would be 50 minutes. So we're going to first of all find out how many potatoes were below 22 grams. So we're going to draw a line up at 22 and a line across, and that is 13. So there are 13 potatoes below 22 grams. And so to work out the probability of picking one below 22 grams, it's the amount that we have below that amount, or below that weight, over the total amount of potatoes, which will be 20. So it'd be 13 over 20, which is equal to 65 over 100. So that would be 65%. So we're going to start by labelling the sides here. So we've got capital A up here, little a down here. It doesn't matter which one you label. Capital B here, little b here, then capital C here, little c here. So you notice the C's aren't really involved at all, but we've got the two A's, we've got the capital A and the lowercase a, and we've got the capital B and the lowercase b as part of the question. And so when you've got a pair or two pairs of angle and sides, you are going to be using the sine rule. And so the sine rule says that sine capital A over lowercase a is equal to sine capital B over lowercase b. Now you might be wondering why I've put sine A and sine B at the top, when sometimes this is written as the lowercase a and lowercase b at the top. Well, if we're looking for the angle, which we are here, we're looking for capital A, you put the angles at the top. If you're looking for the length, you put the lengths at the top. Okay, so we're going to fill this in. So sine, we're just going to leave that as sine A, because it's just, or sine x actually, shouldn't it be? Sine x over, and then lowercase a is 6, equals sine B, the angle is 35, over lowercase b, which is 7. Okay, we're going to work out what the right hand side is. So that's going to be 0.081 blah blah blah. And then we're going to be solving this. And the first thing we're going to do is times by 6 both sides. So we get sine x is equal to 0.491 blah blah blah. And then we're going to inverse sine both sides. And so we have x equals 29.448 blah blah blah. And our answer wants to be rounded to 2 decimal places. So we're going to put our answer as 29.45 degrees. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got 2 radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagram as 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realizing is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got 3 of the sides, we can work out the last one. So angle DOB is going to be 360, take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360, take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360, take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference, and the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should really put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead, and we've got 3 of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know, so the 228, the 13, and the 66. And the reason being the same as before, so angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. We have a +2 on the outside of a function, which means that the y coordinates will all just shift up twice, shift up 2 places. So if I look at this point here, I need to shift that up by 2. If I look at this point here, shift that up by 2. The bottom will go to 3, and we're just going through shifting all of the coordinates up, and then just drawing our new function. I'm going to start off by labelling this triangle. So we've got a big A, big B, big C, and the opposite ones are little a, little b, and little c. And we've got to figure out whether we're using the cosine rule, sine rule, or something else. We've got 3 lengths, and we're looking for an angle. So whenever we've got 3 lengths and an angle involved in the question, it's definitely going to be the cosine rule. And we've got to figure out which of the cosine rules we're using, because there's 2 variants, one when you're looking for a length and one when you're looking for an angle. And we're clearly here looking for an angle. So the cosine rule I'm going to use is cos A equals b squared plus c squared minus a squared over 2bc. And all that is, if you don't know what this formula is, it's just a rearranged variant of the a squared equals. So it's just rearranged. And it helps if you remember both of the formulas for the cosine rule. It does make things a bit easier. So we're going to write it again, but this time with all of the numbers and letters in that are in the question. So instead of b squared, we've got 9 squared plus, and then the c squared is 6 squared, minus the 4 squared over 2 times b, which is 9, times c, which is 6. And when you do that on the calculator, you get 0.935 blah blah blah. But that's what cos x equals. So if we try and solve that now, all we need to do to both sides is the inverse cos. So we're just going to do the inverse cos of 0.935, etc. that's on the calculator, and that gives us 20.741, blah blah blah. And it says it wants it to 2 decimal places, so that's going to be 20.74. So I'm going to first of all just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is one section, we've got 4 of the sections from M to C. So just put like notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. That's why it's a nice, easy way to show that A to M is 1/5 of that distance. Let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M. We've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M, and we know that that's going to be B to A plus A to M. We know B to A because it's labelled, it's just A. And we know A to M because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 A plus 1/5 B. And so A minus 1/5 A is going to be 4/5 A. And then we've got the 1/5 B. So it's going to be 4/5 A plus 1/5 B. There are two shapes we're interested in this question. There's this sector here, which we can work out the area of. And there's this triangle here, which we can work out the area of. What we do is we work out the area of the sector and then we subtract the area of the triangle. So I'm going to start off by working out the area of sector. And we know that that is the angle that we have of the circle times by the area of the full circle. So the angle we have is 39 over 360. And then we've got pi times 10 squared. Type that into your calculator and you get 34.033 blah blah blah. Next we're going to find out the area of the triangle. And we use the, well, if you have a look at the triangle, we've got 10 centimeters here because that is also a radius of the circle. So we've got two lengths and we've got an angle, so we can use the half AB sine C formula. So we've got half AB sine C. And so A and B are going to be our lengths, and C is going to be this angle here. So we've got a half times 10 times 10 times sine the angle, which is 39. Then when you work that out, you get 31.466 blah blah blah. Okay, so to work out the area of the segment, all we're doing is the area of the sector, like the full area, take away the bit we don't want, which is the triangle, and that will leave us the area of the segment. So we're going to do the 34.033 blah 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 take away 31.466, blah, blah, blah. And what I've done is I've saved them on my calculator, so I can do it precisely. And when you subtract them, you get 2.567, blah, blah, blah. Once it's 2 decimal places, so we're just going to round that to 2.57. To find the inverse, we're going to first of all, instead of writing f of x, I'm just going to replace it with a y. And the trick of finding the inverse is to swap over the x and the y. So we're going to swap them over. I'm just going to do it over to the right hand side over here so we've got a bit of space. Now the challenge is to get it so that it's y equals rather than x equals. So we're going to start off by multiplying both sides by 4. And that will give us 4x on the left hand side, and it will get rid of the fraction on the right hand side, which was kind of the point. Next we're going to get rid of that minus 6, so we're going to add 6 both sides. And then finally we're going to get rid of that times 5 there by dividing both sides by 5. So we've got 4x plus 6 over 5 equals y. And we use y as a replacement for the inverse function of x. And so we're just going to say the inverse function of x, which is what that minus 1 means. It means inverse, equals 4x plus 6 over 5. To solve when we've got two equations that aren't linear, and here we've got a linear and a circle equation, what we're going to do is we're going to solve by substitution. We're going to substitute one into the other. So here we're told that y is equal to 3x plus 11. And we actually have a y in our second equation, so what we're going to do is just substitute it in. So we've got x squared plus, and instead of y, I'm going to say what the first equation is. I'm just going to replace it for what y equals in the first equation, which is 3x plus 11. And it's y squared, so it's that squared, equals 125. Okay. Now we need to expand the brackets there. And so we're going to have x squared, and you can use any method you want. And don't forget, when you square brackets, that's just going to be 3x plus 11 brackets 3x plus 11. So we're going to do 3x squared, which is 9x. So how are we going to write this? So plus 9x squared. And then we've got 3x times 11 plus 3x times 11, which is 33x plus 33x, which is 66x. And then we've got 11 times 11, which is 121. Now at this point we want everything to equal 0 because it is a quadratic. So to solve it we need it to equal 0. So we're just going to tidy it up and add the bits that need to be added. And we're also going to subtract 125 both sides to get it equal to 0. So x squared plus 9x squared is going to be 10x squared. So we might as well just write it as 10x squared. We've got 66x just on its own. And we've got 121, take away 125, which is minus 4, equal to 0. Now it says it wants our answers to 2 decimal places, so chances are these won't factorise nicely, so we're going to be using the quadratic formula. And so we need to find out what a, b and c are. So a is the number before the x squared, the coefficient of the x squared, which is 10. B is the coefficient of the x, which is 66. And c is the number on its own at the end, which is minus 4. The quadratic formula will be minus b, and I always put the values we substitute into brackets, because if they're negative that really helps us. Plus minus square root of b squared minus 4 times a times c, all of that over 2 times a. When you put that as a plus, then into the calculator we get x equals 0.060 blah blah blah, and when you put a minus there, we get the answer of minus 6.660 blah blah blah. Now you might think, well, how are we going to find out what the y's are? Well, if x is 0.06 blah blah blah, we've got an equation here that says to find out what y is, we times the x by 3 and we add 11. So we're going to times that first solution by 3, then add 11, and that gives us that y is 11.180 blah blah blah. We're going to do that with the next solution, and we're going to times it by 3 and add 11, and when we do that we get minus 8.980 blah blah blah. We're going to round each of these to 2 decimal places, so we've got 0.06 and 11.18, and the second set of solutions is minus 6.66 and y equals minus 8.98. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.